Hi everyone, in this video we'll go through differentiation of implicit functions. All this while we saw differentiation of explicit functions, that is where y is dependent on the values of x, right? This entire function has only has x and y is on one side. This is explicit function. Implicit function is nothing but you have both x and y mixed in the function, right? There is x and there is y, both combined together. So this becomes an implicit function. So what this means is the function, the value of the function changes based on the value of x and value of y. Whereas in explicit, the value of y changes based on value of x. But here, value of y depends on y also and depends on x also. So now how do we differentiate implicit functions? We'll take an example here. We'll take this example. Let's take 3x square plus 4y square is equal to 10. It's a normal way of differentiating, just that we'll have to put dy by dx. Now, if I differentiate this, let's differentiate this with respect to x. So what will happen? 3x square. What is derivative of x square? 2x. What is derivative of 4y square? So you take the derivative of y square here. What is derivative of y square? 2y. Right? And then you'll have to put dy by dx. Right? You'll have to differentiate with respect to x. You'll have to put dy by dx and derivative of y square. Both you'll have to put. So this is the only difference, right? So now this will be 6x plus 8y into dy by dx is equal to 10. Now I can just find dy by dx by shifting everything to the other side. So I'll get dy by dx is equal to 10 minus 6x by 8y, right? Now let me take 2 as common here. 5 minus 3x by 8y. 2 1s are 2 4s are. So I'll get 5 minus 3x by 4y. This is dy by dx for this function. Now let's take another example. Here, if you notice, it is x into y, right? So it is log x into y. There is a logarithmic property, right? There is a log property which says log x into y is log x plus log y. This is log xy. You can write it like this. So let's split it like that. So we'll write log x plus log y is equal to x square plus y square. Now let's differentiate with respect to x. So log x is 1 by x, log y is 1 by y, and we need to put dy by dx. Because we are differentiating y with respect to x, so we'll have to put dy by dx is equal to x square is 2x, derivative of y square is 2y into dy by dx. So other than x, if you find any other term like y or z or t, then you have to put d by dx of that particular term, be it y or t or z, right? Now what we'll do, we'll bring dy by dx to one side, right? So, and we'll take everything else on the other side. So we'll get 1 by y dy by dx minus, I'm bringing this here, 2y dy by dx is equal to, I'll take 1 by x the other side, you get 2x minus 1 by x. So now I'll take dy by dx as common. So I'll get dy by dx is equal to 1 by y minus 2y is equal to 2x minus 1 by x. Now I'll take LCM here. So I'll get x is the LCM, right? X is the LCM. So this will go x times 2x square minus 1. This is dy by dx into, again let me take LCM here. So this will be 1 minus 2y, LCM is y. So it will be 1 minus 2y square by y. Now I'll shift this here. So I'll get, I just want to find dy by dx, right? Everything else should be shifted to the other side. So when I shift this here, this y which is a denominator will go to numerator in multiplication. Here it's division, here it will become multiplication. And what is the numerator will come to denominator. It will get reversed. So this is dy by dx. So what do we get? 2x square minus 1 into y by 1 minus 2y square into x. Now let's take this third problem. We need to differentiate this particular function. Whenever you have powers like this, right, you have to take logarithm on both the sides. You have to apply log on both sides. So we'll apply log on both sides so that we eliminate the power, right? We need to remove this power. To remove the power, if you apply log, the power will go away. How? So we'll first do that. Log of x to the power of y is equal to log of y to the power x. Now there is a logarithmic property which is log m to the power n is n log m. So the power that is here can be shifted here, right? So you don't have the power, you eliminate the power. Now, using this property, what we will get? We'll get y log x is equal to x log y. So you notice this power, it has come here. Now I'll differentiate with respect to x. So if I differentiate, I'll get y into log x. Now you'll have to apply product rule here because there are two functions here, y and log x. So we'll have to apply product rule. So product rule states that you take first term into derivative of second term. What is derivative of log x? 1 by x. Plus second term into derivative of first term. Derivative of first term is 1 into dy by dx. We'll have to always put this dy by dx is equal to, similarly here, we'll have to apply the product rule. X into derivative of log y, which is 1 by y into dy by dx, plus log y, that is second term, into derivative of first term. Derivative of x is 1. We get y by x plus log x into dy by dx is equal to x by y dy by dx plus log y. So let's bring all dy by dx together on one side and we'll take everything else to the other side. So what I'll do is I'll take log x dy by dx. I'll shift this here. So it'll be minus x by y dy by dx is equal to log y minus, I'll shift this, y by x. So now I'll take dy by dx is common. So I'll get dy by dx common. If I take, I'll get log x minus x by y. Now here, let me take LCM here, right? So LCM will be x. 1, if I have to get this particular LCM, I have to multiply 1 x times. I have to multiply x times, but I multiply the numerator. So it will be x log y minus y. Here also I need to find LCM, right? So dy by dx, y is the LCM here, right? So I have to multiply this y times. So I'll get y into log x minus x is equal to x log y minus y by x. Now I'll keep dy by dx here and shift everything else to the other side. So I'll get dy by dx is equal to x log y minus y by x. I'll shift this. So this is going to become into y by y log x minus x. This is nothing but dy by dx is equal to y into x log y minus y by x into y log x minus x. So this is the derivative of this function. Now let's take one more example here. Here again you have powers. So here what we will do, we'll differentiate both the sides with respect to x. What is differentiation of 2 to the power x? We'll have to remember that formula. D by dx of a to the power x is a to the power x into log of a, right? Instead of a, we have 2. So we'll write it as 2 to the power x into log 2 plus differentiation of 2 to the power y. Same thing. 2 to the power y into log of 2, and we'll have to write dy by dx because there is y here is equal to, same thing, same formula we'll use, 2 to the power x plus y into log of 2. Now we'll have to go with chain rule. You have x plus y. So derivative of x is 1 and derivative of y is 1 itself with dy by dx. We'll have to put dy by dx. So what we'll do is, let's multiply this. So let's take log 2 as common here. Log 2 is equal to log 2 into 2 to the power x plus 2 to the power y dy by dx, which is equal to 2 to the power x plus y into log 2 plus 2 to the power x plus y into log 2 into dy by dx. I have multiplied this with this. So here I can take log 2 as common. So I'll get log 2 to the power x plus y plus 2 to the power x plus y into dy by dx. So here there is log 2 here and log 2 here. Both of this will get cancelled. So what am I left with? I'm left with, let's write this, 2 to the power x plus y plus 2 to the power x plus y into dy by dx. Now we'll shift dy by dx to one side. So what will happen? 2 to the power dy by dx. I'll shift this here. So it'll be minus 2 to the power x plus y into dy by dx. Let me shift this to the other side. It will be 2 to the power x plus y minus 2 to the power x. I shift this here. Now I'll take dy by dx as common. So I'll get 2 to the power y minus 2 to the power x plus y is equal to. Now let me shift this here and just have dy by dx. So I'll get dy by dx is equal to 2 to the power x plus y minus 2 to the power x by 2 to the power y minus 2 to the power x plus y. Can we further simplify this? Yes, we can take 2 to the power x common here, and here we can take 2 to the power y. Why? Because 2 to the power x plus y can be written as 2 to the power x into 2 to the power y. This is exponential law, theory of indices. I can split this and write this as 2 to the power of x into 2 to the power y minus 2 to the power x by here also I can split it and write it like this. Now what will happen? I can take common. 2 to the power x is common here. So 2 to the power x, 2 to the power y minus 1 by 2 to the power y 1 minus 2 to the power x. Now you notice this. There is another exponential law. If you have something like this, you can take this y on top. So you'll get 2 to the power x minus y into 2 to the power y minus 1 by 1 minus 2 to the power x. This is dy by dx. You can write this like this also. You can put as 1 minus 2 to the power y and take minus outside. Similarly here also. And denominator also you can write 2 to the power x minus 1 and you can take minus outside. Right? Like this. But here minus and minus will get cancelled. Minus and minus will get cancelled and you'll be left with this expression. Let's take this particular problem. We'll have to prove that dy by dx is this entire function. So first what we'll do, we'll take log on both sides because we have powers here, right? So we'll take log on both sides. We take the log so that we can eliminate the power because there is a log property, right? Log m to the power n is n log m. So using this property, it will be y log x is equal to y minus x log e. Log e is 1. So this is going to be y minus x into 1 and y log x. What I'll do, so I'll bring y to one side and x to other side. So what I'll get, y log x minus y is equal to minus x. I'll take y as common. So I'll get log x minus 1 is equal to minus x. So I'll shift x to one side. So y is equal to x by, this is in multiplication, right? It will get into division. It will come to denominator. Log x minus 1. Minus is here. Basically, y is equal to minus x by log x minus 1. We can also write this as y is equal to x by 1 minus log x. Right? If I take minus to the denominator, I can write it as 1 minus log x. Right? So that numerator becomes positive. Now I'll differentiate with respect to x. So I'll get dy by dx. Now I'll have to apply the quotient rule. What does quotient rule say? Denominator into derivative of numerator minus numerator into derivative of denominator by denominator square. So denominator we have 1 minus log x into derivative of numerator, that is 1. Numerator is x into derivative of denominator, this one, 1 minus log x. 1 is 0. Log x is 1 by x by denominator square, which is 1 minus log x the whole square. So now I'll get dy by dx is equal to 1 minus log x, minus and minus will become plus. So it will be x by x to 1 minus log x the whole square. X and x will get cancelled. I'll be left with 1. So this is nothing but 1 minus log x plus 1 by 1 minus log x the whole square. This is nothing but 2 minus log x by 1 minus log x the whole square. So this is nothing but RHS, right? Is equal to RHS, hence proved. With this we have come to the end of this particular topic. If you have liked this video, do press a like and share it. Thank you.